Good morning, everyone. And today is the May 25th and our weekly SIG Node community meeting. Welcome, everyone. So we have a full of agenda today. And let's start our today meeting as usual. Sergey, Sergey, are you around? Do you want to update us about the PR status and also the strategy status here?
I think Sergey might not be on the call, so I am happy to jump in on his behalf. I don't have the numbers for the from the script for the meeting notes, but anecdotally, I could say that we've been merging some PRs. I've certainly been for those. Sorry.
Oh, all of a sudden you are freeze. So that's why.
Oh, I see. Sorry, my Wi-Fi is a little out there. So I was just saying that PR seem to be moving along well. The triage column is mostly empty. We definitely still need more reviewers and more help with triage, but velocity seems like pretty good right now. And the more folks who get involved, the more we can sort of burn down the backlog. Because we still have lots of PRs that are waiting on reviews, even if things are mostly chugging along.
Thanks, Elana. So maybe we move to our agenda. And the first one, actually, is you, Elana, talk about the termination report.
Yeah. So I put this one on the agenda and put together a doc because we have been chasing down a lot of race conditions in the kubelet and issues with pod spin up and deletion. And I've been chatting with Ryan and Clayton, and Clayton is here. Hey, Clayton. Do you want to jump in and talk about some of the stuff from the doc that we put together?
Yeah, and Ryan and Elana and I have been like chasing some of these for a while. We had a bug 2 years ago, which was like you could have a pod that was that always failed. So like you could have a job that returned exit code 1 all the time, and very rarely it could actually return 0. That was due to a race condition in kubelet status reporting. We chased some stuff. Usually had some feedback. We knew there was another race somewhere else, and so we kind of put in a best effort check that handled it. The test case that we put in to simulate that actually creates and delete. Like it creates a pod and then immediately tears it down, and the container is supposed to return 0, and so the test was checking to return 0. We had a couple places where that would hang or like fail for a long time. And so it was like, oh, there's something weird going on, but it was really rare. As I was digging into that last week, I realized the actual issue is what would happen would be that just because of the way teardown happens, you actually would not, the various bits of the kubelet that are like, hey, is this pod terminated so I can start cleaning stuff up? We're actually vulnerable to a race condition where the first container hadn't been started. So there was no strong synchronization in the kubelet that allowed you to know that the pod is transitioned to, basically there's like 3 phases of a pod's life cycle. It's like, doesn't have any containers yet. Once the kubelet sees it, it can start having containers. And then when it's stopped or evicted or shutting down, you need to know that no more containers can be created from this point on. And most of the other kubelet cleanup loops were doing a very, very, very incorrect check for that. They were just looking at whatever copy of the container status they had, which could be wildly out of date. And now it turned out that status check wasn't checking init containers or ephemeral containers. So it was also just wrong. So after some quick discussion with Elana and Ryan, my proposed address and what's in the doc that Elana wrote up was really great that she did that, and I was adding some notes, is the life cycle of a pod is pretty predictable and we need some strong guarantees. We already have the pod worker. I think the pod worker today exits too early. And so my proposal and what I was hacking around and testing was effectively that the pod worker, from the moment we start building up a pod to the moment we've fully torn the pod down and generated the final status, because there's no more running containers on teardown, would all happen in a single per worker loop. We actually found I was linked into other problems that people have found. So there's an issue with graceful termination, which is you're supposed to be able to shorten graceful termination, but the way that that was being handled didn't necessarily guarantee that the shorter duration, like, so you create something, you say, wait 30 seconds, you're allowed to at the API server, and this is part of the original design, say, oh, no, only wait 20 seconds. And if 20 is shorter than 30, the kubelet's supposed to shorten it. That logic didn't actually fully work. There was a PR for it. I actually think to correctly do that, you need to be able to know what the last value was in a deterministic fashion in the kubelet. The other person had already started changing that in the sync worker. So again, I think it's right for us to combine, have the sync worker be the source of pod life cycle tearing up, the immutable transition to starting to tear down, the transition from when there's no more running containers to when the pod is cleaned up. And actually, I found a couple more race conditions as I was going. So I'm pretty confident that kind of pod logs are actually being torn down too early today, because the loop that tears down containers also tears down pods, but that's not actually tied to pod shutdown. So I actually was able to trigger a race condition in a test that I had seen before, where a pod reaches success, and then we try to go see the logs for it. And just because the sync loop was kind of slow, most of the time you'd have like 10 or 15 or 20 seconds before it got torn down. I was actually able to make it happen instantly, because in the sync worker, I was tearing down the containers, and the fix is pretty obvious, which is we want to guarantee that container logs stay until the pod is deleted or an eviction or a garbage collection happens. And by unifying some of this logic, that became a lot clearer. So there's a bunch of like little bugs all over the place that I think this helps. It's not a lot of, basically all the places in the kubelet that are saying things like, hey, given the current pod I have, go ask the status manager for the container state, go check running containers. They basically just become calls to the pod worker, which has a locked, synchronized, immutable one-way transition map that says the sync worker has started up, so there could be running containers. Sync pod, and so I also split sync pod into 3. There's setting up a pod, there's stopping the containers, and then there's cleaning up the resources. And cleaning up the resources matches what you have to do in the status manager before the final delete is sent. So those are all basically unified. As the pod worker goes through those phases, it checks to see that we're not transitioning through an illegal state transition. It sets the map, and then everybody else in the kubelet just says, like, they make the same calls they did before, but they're consistent and they're one way, so they can never regress. I'm hoping that I can get I think I have almost all the bugs. I'm still chasing down some cases where I didn't understand the kubelet enough. Mirror pods are still broken, as they always are. And I need to go fix one thing there. But if folks can read the doc and give feedback on it, did it sound sane? I saw Don nodding, but Don is easily convinced by my subtle lies sometimes.
One thing I should mention.
Clayton, I want to invite Yuji here. Yuji will feel so relaxed. Someone repeat, basically say what's the original design. And here, I know, I believe the single pod and also pod worker, or it is the first time we will introduce to the synchronization to the Kubernetes. And I thought the original, is the pod event. In the old code, maybe some optimization mess up those events. So distributor, so it looks like still it is just optimization. Last 2 years we added, we have, even recently, I think the half year ago, we have the huge project. People want to even more optimize the status report. So, but to not really enforce those synchronization, those pod related events. So that causes some of the risk condition. So what you said here, it is so makes sense. I also see the Nantal is here today. I think that's kind of, you basically repeat and original design here and why we are so keen on those core design. But obviously we try to optimize and obviously some bug introduced. Thanks.
And
yeah. Yeah, actually, I just recently had a discussion with Chen from SIG Storage, and basically we also encountered some risk condition around similar to what you described. Is that when you create a container and when you create a pod and it's not running yet, it's pulling image, and now you try to delete it immediately, and somehow the volume will go into a weird state that the actual volume is not mounted, but Kubernetes think that it should mount and create a local directory. So the pod is using a local directory, but it actually should use a volume. But anyway, it goes into an inconsistent state, and we discussed internally, and we also discussed several options. And one of the options is that to make sure that pod worker handles the life cycle of the pod, and the other logic like the pod clean, the cleanup, we have a big cleanup loop. So I think for that one, the risk condition is caused because both the cleanup and the pod worker trying to do things, and we thought that pod worker stopped working, but it's still working. So if we have a clear indication about whether pod worker is still managing the pod, if it is, cleanup shouldn't kick in. And so to avoid the risk condition, only when we know that pod worker routine is gone, we can use use channel, use log, use anything to make sure that it's gone, and then the cleanup start doing work. Then it can avoid this kind of issue. So just another example similar to what you described.
And it actually is kind of reassuring because most of the race condition that was originally caught was the short running. It could happen later in some cases, it would be unlikely, but cleanup in general is working. We've kind of as we've improved cleanup over the last couple of years, the nice thing is that we've kind of improved and concentrated where cleanup happens. And as I went through, I was trying to just verify all those places. And I think we have gotten a lot cleaner so that it's easy to say, here's a set of things that we have to clean up. Having that list actually means we could just do that synchronously, which also reduces tail latency on shutdown. But there's some trade-offs there that I think we should discuss. Don, you brought up the point about status. So the thing I was actually seeing before with status was some of these second order effects with cleanup. With status, there was basically, I think it was taking us 10 seconds on average to sync some of the important events. What I'm seeing today in the code is it can take somewhere between 10 seconds and 20 seconds under moderate load, or 30 to 40 as more pod workers show up to actually finish the termination of pods. Part of that is actually just the sync loop intervals, which is a defense of, it degrades gracefully to a more predictable performance mechanism. But also status is easier to reason about now because we can actually look with the pod worker having the full life cycle. What I was finding was that I could actually make an argument that we would know the time between different phases much more accurately because it's one spot, which also would help us with putting performance measurements in place that would let us assess tail latency of pods shut down and measure it accurately, as well as things like when we do go optimize status reporting, we'll have a much better understanding of when the status should be done, and we can compare against it. But yeah, the places that were a little weird were some of our terminology is a little inconsistent. So in eviction, we would say terminated pods, but those are actually terminating pods. And then pod deleted, is pod deleted was being used a couple places, and it wasn't really the pod is deleted. It was either kubelet side eviction has been requested, in which case the kubelet wants to get rid of those resources, or the user has told us to delete it, in which case we can get rid of those resources. That was kind of being used inconsistently. So just going through and reviewing, it's easier to put better names on those that are centralized, like should pod resources be reclaimed, which makes it easier for someone adding a new loop or looking at it to reason about. It took me a couple of days to bring everything into context, and I still think there's some subtle stuff, but it has helped at least to look at it.
I was looking at your first PR, and I know I've been telling you for the last couple of days I'd look at this, but live code review is fun. I don't. You said static pods weren't working right. I was trying to think through the changes we did last year to handle, I guess, proper shutdown of a static pod when you change the file on disk. And I remember having to spelunk my way down into the pod killer stuff, and I see that you've gotten rid of the pod killer, or I can't find it.
Pod killer is part of the pod workers is the pod killer. So all pod killer function is merged with sync work, the pod worker in the PR.
What happens when a kubelet starts and sees pods that should no longer exist? Like all the cleanup loops for
all the cleanup loops are basically the same. So the cleanup loop would look at all the like containers or volumes, and it would say, here's the set that shouldn't work. And then all the cleanup, as far as I can tell, the cleanup loops are actually correctly cleaning up all the pods that are non-existent, because I didn't change the cleanup loops except to say, like, the cleanup loops have a bunch of gates in them that say, is the pod in this state, or does it exist or not exist? I made those correct because they were not correct. Like the places where we were checking our containers running was racy and was vulnerable to a race on startup, or on restart of a kubelet, or on restart of a node. So that is a place where a race would exist. In practice, most people wouldn't hit it, but you could actually start tearing down the containers or the state you needed from the previous reboot or from a previous start of a kubelet due to that race condition. That's been mostly fixed. So I didn't really have to change that logic. It's just the check is correct from the, should this pod exist and what phase of its life cycle is this pod in?
Yeah, I guess what I was trying, I thought I had to check myself afterwards, but I thought when we discover C groups and processes running that correspond to pods that no longer are tracked from a file source or an API source, that we still went through the pod killer flow and there was no pod worker there.
I'll go double check. As far as, and this may be like one of the tests that was broken, like the core tests all work, which was another example of any place where I knew it was broken and the EDE tests did not catch it is a place where we probably need to add some better EDE tests. Like the node EDE test caught a few of them, but for instance, like some of the race conditions, like the fact that init containers were not considered at all means we need to have an EDE test that's a little bit like the existing create then delete for init containers. There was one with pod logs aren't being preserved. That was a race condition that I just, I only, the test flaked and didn't fail. I actually think we need a test for that, which is we need to put the pod into terminating and verify for the majority of the life cycle of the terminating pod that we can get the pod logs. That'll be a little bit weird to test, but I think it's possible.
Yeah. And then it seemed like on Slack, we had some discussion where terminology is probably overloaded. What are you calling a shutdown as a consequence of observing like a systemd hook that says this node's going to power down? And are you calling that something different than out of resource eviction?
Yeah, so I didn't change any names of that. So like eviction, so everything, if you want to terminate a pod from the kubelet in a scenario, you basically send the sync pod kill event to update pod. So eviction through the kill pod now wrapper, and then you pass it. Obviously you'll do status mutations that say like that make it permanent or not. So it's kind of the soft admission failures in the sync loop are the only thing that don't go through that mechanism, but it puts the container into the same state, which is a soft pod termination. So if pod emission happens, you're still in the sync loop, you're still in the building up, but you get to the point where you realize you should be not running and you shut it down. So it's like one of the first checks. All other like eviction, graceful shutdown basically just call kill, and they either mutate the status or they don't. The issue I saw from a terminology perspective was graceful pod shutdown today is behaving like eviction. when you shut down the node gracefully. And I don't think it should, because there's no expectation that that pod can't restart on the next time the node comes back up. That was a minor thing I caught. I tried to unify all of the code that is terminating pods. So there's only one method right now that anybody can send to tell a pod to shut down that's not inside a sync pod worker. So kill pod is only inside sync worker, except for the cleanup loop. I think that was maybe the one. And maybe cleanup even should be more closely aligned with the pod worker, to your point, Derek. But we could tag it like with a to-do or something. Like cleanup of pods that don't exist is similar enough to pods shutting down that they should be aligned, so that you know when you can use kill pod or not. But I didn't change the definition of eviction. I didn't change graceful shutdown, and I didn't change.
So we do have like a eviction and also out of resource test, but at the node E2E, we
Those
never.
are passing, as far as I know. So I did not break those.
I know. No, I just want to say that, but there's the many to-dos we didn't finish. The reason it is we need the support from other community, like the Kubernetes community, because I think back then the community really keen about a lot of what is conformance, right? So that's why so this is why I invent something called the node level of the conformance. So, but back to this, the PLEG, like the management, actually we used to have the integration test for those kind of things. And unfortunately, those integration tests also is no maintenance. So that's why to focus, for the community can be focused. So we later only focus node E2E. Then later, finally, Kubernetes have the cluster level of the conform test. Then we focus on conform test. So you can see like over time, we are focused on smaller, even with smaller core functionality for try to make those is the E2E, have the E2E test. So we give up a lot of other tests, even like the said weather related stuff. We also have integration test, and the PLEG, we also have integration test. So maybe we could revisit those kind of things. Even like the node perf test, performance test for the container runtime, and also know the level of the performance from the Kubernetes level, we basically give up at this as the SIG Node community, because due to the reorg, due to many things, we last 2 years, 3 years, we give up. Gradually, just update here. We maybe can pick up a lot of things, come back, maintain our reliability.
And the nice thing is at least from the behavior a user expects, most of our EDE, like the gaps I was seeing were like places where in the EDE of like, have we ever really defined how long it is that you can get logs from a terminating pod? No. Should we? Probably, because it's racy right now, so people are probably expecting it to work. So like even that's like a great example of a conformance style test that's pretty easy to write with a little bit of cleverness. I did really regret not having reliable and easy to run integration tests for some of the interaction between the cleanup loops. And some of that's tough. Node EDEs could cover that. But like Elana and I were talking about yesterday, just about there were some definite places where this was harder for me, even kind of knowing what the intent was and having a lot of the backstory, because I couldn't check the mid-level invariance without just firing up a local cluster and running it, which felt like we could do better for testing specific scenarios that are kind of like whole kubelet. But knowing how complex all the flags for kubelet are, there's also some limitations there. So be happy to identify some places where I think would have helped here as well.
Yeah. So if Lantel or myself want to help review on this, and I know Clayton, I'll help you with the Node EDE mirror pod stuff, because
I'm pretty sure I just reversed the order of a UID, but I'm not ruling out the possibility that some of the other weirdness we've seen on static pod restarts I might have broken a workaround where this might actually help us fix it more cleanly, just because static pods are subtly different in their termination logic, because they will come back. That'd be actually a great opportunity to go and make sure that I understand it as I'm putting some of this other stuff in space, so I can help add more tests.
And then Don, you had mentioned like the perf test. Renal and I were having some discussion with some folks at Red Hat that wanted to better look at pod startup latency, I guess. And one of the areas we were trying to see is if we could have them bring that test dashboard back to life. I don't know what the timing on that will be, but
sure.
Definitely.
That one also have tons of what to do based on original design. So I can share if you want. I can schedule meeting, give the status, current status, and then what we can move forward. And also there's the SIG instrument, which is David the dashboard, right? So from the SIG Node. So we also want to do more from the instrument and those kind of things. And then we can, that's also from the SIG Node initially, basically from us, we want to instrument enable those kind of things. And so you can easily monitor of the latency.
Yeah, I would be happy to put that in this PR, especially because I was noticing that the sync latency isn't quite correct. And some of the latencies that matter are like from the time someone requests shutdown to the time we delete the etcd object is unmeasurable today. But it could be measurable, and like there were some options. So I'd be happy to tackle some of that and then tee up some of the discussion as well. Certainly with this change, at least for unloaded kubelet, shutdown latency becomes much more predictable. It's not a regression, and the tail is pulled in a bit. It's not fundamentally changing like some of the like the status loop is now the biggest, like under load, the pod status worker or pod status manager and its final updates are the longest component of shutdown from an observable perspective. The other fixes I had that I was playing around with and like, improving that would be probably even better now because we're not dependent on the cleanup loops in this approach. So if we exit with success, basically the status manager has everything it does. Like at that point can basically declare the pod done because we've reached our guarantees. That should get the P99 of pod latency down tremendously. So I'm kind of incentivized to like get the right instrumentation in so that we could say like, hey, here's what we're getting now. And we're seeing how bad it is. And then when the status manager improvements, like if somebody gets time to come back and reassess them, we might actually see a significant reduction in the time to shut down, which matters for anything short running.
Clayton, do we want to touch on the pod level termination grace period seconds being set to 0 bug? Because that was kind of the thing that was what set us down that rabbit hole.
And yeah, like Jordan had been recommending to people in E2Es because Jordan's not the best person sometimes, and but in E2Es we were force deleting pods, and so I thought we were force deleting pods in EDE tests where people were actually invoking a deletion, but it turns out that we actually allow pod termination grace period seconds on spec to be 0, which was not the intent at all. And I don't know how it's gone 5 years without me noticing that. So that's what the PR originally was. I was fixing it to make it impossible to set 0 from a pod spec because that completely takes the kubelet out of the chain. It has a whole bunch of resource implications for the kubelet. The original intent of graceful deletion was not, or forced deletion was not for it to be a standard part of the workflow. As part of that, I was proposing making 0 behave like 1. Elana pointed to another bug where negative also works. Jordan and I were just having a brief chat yesterday where he was suggested that negatives and 0 are basically the same problem. We could fold those together, get validation in, but we would have to honor the old value any invalid value basically becomes 1. So I'd like to see that PR and the approach I had combined. Jordan was making some suggestions on the PR because he had questions about it, but it would be an API change effectively, where we would say you can no longer request forced deletion of a deployment or replica set or stateful set. So I understand that this would make things work. I feel like taking kubelet out of the loop at a workload level is not a behavior that I think is encourageable, but I'm open to alternatives.
Clayton, I update, I give some background. Basically, I think there's a many debate between us and also community. So many feature added because we also don't want the Kubernetes in the middle for a lot of the force deletion behavior scenario. So that time I basically debate a lot of time. But I also don't want it in the middle. I just want to say there's also, if we need the Kubernetes really until Kubernetes really delete all those kind of things clean up. And so I basically want, initially what I want, it is the Kubernetes observe, at least observe that event. And the pod event will be generated. Let Kubernetes deleted. But then there's a lot of people think about, they don't want to wait that sync pod duration and to delete. Anyway, I forgot all the reason, counter argument, and so.
And that is a fair point. Like if you have a name locked and you want to, if you're doing a single pod use case where you're going for end-to-end latency, but I guess the question is the only workload controller we have that's dependent on names is stateful sets, and force deleting a stateful set is a non-goal of stateful sets except to resolve a partition. So then the question would be like, if we can improve the performance is slow, and that by improving the kubelet, if we can get it down to like, because I do think that if we don't wait for containers to be removed, which is another thing in the PR that is worth some discussion, we're talking volume cleanup, which is the slowest part of it. So volume cleanup, even with the check I was doing, was still seconds. QoS C group removal is very fast. And the sync, the pod sync loop, if it had the right info, could basically be near instant, with the exception of throttling. So I do think it's actually pretty possible that if we could improve volume cleanup, we could get down to 2 seconds. Like if you had a pod that had a termination grace period of 1 second, you could probably get down to finishing in 2 seconds. Would that be short enough, or does someone still need it even faster?
This is if volume cleanup, deletion, block a single pod, that's the wrong. Original design is not this way. Original design, it is just generate clean action. That came from me. I said, okay, once we watch off the pod event, no matter it is the container creation and the container delete, all those kind of things, and even like you generate, once you have those kind of things and you generate an event, pod worker will generate clean up event associated with this one and hand over to clean up thread. That's the totally separate worker. Okay. So that's the original design. Shouldn't block this one. So then you basically have a lot like the disk clean up, disk management to deal with all those kind of the heavy lifting work.
So that's roughly what my change looks like, which is if you said grace period 1, the first event comes in, it makes it to the pod worker. Right now, we're not interrupting the pod worker, but in order to do context shortening, we should be able to cancel the sync pod worker by passing a context to it. So that would be that was listed in there. The event, you see the delete, certain events transition to terminating would be allowed to cancel, shortening the grace period would be able to cancel the current sync, which would then just tee up the next one. We'd call kill pod. Kill pod would be done. And if at that point we have enough info to fire the final status, it's taking a while today under load because the status manager is not optimized for per pod latency. It's optimized for throughput. But I think my change is 90% of that, which would basically be, I have that mostly working now. So maybe we just do a follow-up and we can chat some more details about, I think we're actually pretty close to that. It would be a small step for you to where you want to be.
I hope take this chance to do more cleaning up of the disk management. The reason I want this cleaning up, volume cleaning up also is shift and hand over to the different things is just because on disk, there are also, you need a single view about all the disk management, include of the container image download and start log, all those kind of things on the disk. So this is why initially designed it is there's the pod worker for handle of the single pod event and observe, watch about the all this event generated from the API server related stuff. And then there's the separate of the, maybe a group of the disk worker. That's the separate disk worker, but there's the one thing, the single thread monitor entire of the node disk include new image download, track of the image download and the login and also the wallet and on the disk. So that's kind of make this is everything. We haven't finished this totally disk management yet, but for the wallet delete from day one should be delegated to another separate of the worker. So that's the original design. I just share around here because I think a lot of new people here.
I think I accidentally discovered the mind of Dawn inside the code base. And so I was clearly guided by, and actually like I do remember some of those discussions like Derek and I had a while ago. So like, it was actually good for me to bring it all back into context because I could see many of those elements. It's good, like maybe we can do a follow-up at some point soon and go through the PR in detail for, are there other elements we can improve? Because I do think in order to fix some of the race conditions we found anyway, we have to do some of these trade-offs, because the loops that are cleaning up stuff too early, those have to be fixed, or we'll just, you know, it's races that we're just finding and we can easily fix them. So thanks, Don.
Thanks. So I think please review the PR and also read off the doc shared by the Elana, and thanks Elana to converging everything, and the Nantal thanks offered for the review bandwidth for this one. I know you are super busy. So for time checking, and then let's move to next topic. Yangjun, do you want to talk about the containers start time as the metrics here?
Yeah, and there is one issue. Want to get an opinion here. Let me. As we see, issue 101851. We want to expose container start time in Kubernetes metrics resource endpoints, and so we can have two benefits. First, it allows to detect the containers restarts as a container start time change. Second, it allows to speed up metrics for fresh containers. And so I think it works. I want to know about your opinion. Thanks very much.
Thanks so much for joining today to bring this up. And I can provide a little bit more background as well. So on the SIG instrumentation side, Merrick was looking into using the metrics resort endpoint as a replacement, I think, for the summary API. And there were some issues with the CPU usage metrics. So basically, I think he wants to add some new metrics to the metrics resource endpoint. So the container start time and the node start time. And I think David Ashwell took a look, said it seemed reasonable, but we need to discuss it SIG Node. So,
yeah,
I personally think that would be useful metrics, but I want to ask what how you define. Oh, you want the container level start time? Okay, that's never mind. Okay.
Yeah, I think that we have all of this already. We're just not exporting it on that endpoint.
Yeah. We just that's useful for us.
What is the definition of node start time? Is it the start of the kubelet, start of the Linux or Windows host?
Is it based on? Sorry, I'm going to read through the issue.
I originally think node start time. I just brainstorming through here. Original node start time when we monitor, so it's when the node start boot up, and to the node first claim it is the node ready. That's node startup time. Similar to how we claim this is how we claim of the pod startup time. When we first like the duration is when we first have this pod created and being seen in the API server until of all the initial application container start once. So that's about the start latency. At least this is how we initially defined node. That's originally what I defined, and just as the brainstorming through here.
My concern with having the node start time be when the node marks itself as node ready is it can run stuff before then, which would be confusing, right? Like static pods could potentially start before then. Things that I guess tolerate node not being ready could potentially start before then. So
I think a lot of people forget in the signal that we know there's the use cases for static pod. We even last year support some really required of the feature, but again, static pod is discouraged. We know there's the initial cloud, the initial cluster, depend on the static pod. I know no matter OpenShift or GKE, there's the static pod dependency, but I believe in the signal from day one, we said we are discouraged people using static pod all the time, only for the cluster initialization. We know there's the dependency until we address the off-the-shelf self-host of the cluster. So that's why that's most for these cases. But the rest of the stuff shouldn't as the static pod.
So
I think
you can deploy your CNI. So like the node going ready is basically as your CNI deployed, right? And then many folks deploy a CNI through a daemon set just fine, right? You tolerate and not ready.
I think it's not just CNI. Actually, node ready. Actually, in the past, the node ready. I know we relax a lot of things. In the past, the node ready, it is at least the container runtime run once. So you will see container runtime is ready, and then you will see the CNI, or it is the pod set range is being allocated.
Yeah.
So then we claim it is node ready. That's the first time node ready. So.
Yeah, the container start time metric that's in the proposal makes total sense to me. Just clarifying if time of node is, I mean, it's a net new metric. I just didn't know what that was actually measuring. And it wasn't clear what that metric was used for right now to meet the two use cases above. Like if node start time is when the computer was powered up, let's say, then I guess you're measuring the delay from power up to running a container, which seems very useful, versus start of kubelet reporting ready and then running a container, because you would have already been probably running containers.
I see. I was trying to read through this and see where it was used or why it was used. And Merrick wrote, the node metric proposed is not required due to differences in node lifecycle, but was added for symmetry and to simplify implementation of CPU usage calculation. So I wonder if we could get away with not adding that one, or trying to figure out a better use case for it before we add it.
I also want to see that even today, node, when the node first up, and we'll say, oh, Kubernetes burst, generate an event, and then node is ready and generate, okay, node is ready event. This is why what I talk about node startup time. Otherwise, so basically we use to measure it is this node successfully joined cluster and is ready to take any work from API server. So we believe node itself can expose other metrics to say, oh, how long you basically you have other metrics to measure after your kernel startup time and internal ready, because you just pass your log, right? So kernel log, and there are also you can measure, if you look at the node perf, they're actually measure all those kind of things based on the log scan. But do we want to? When we talk about Kubernetes, by default, open source, not each body's production. And actually, we should be most generic data. So the node startup, for me, it is more like, okay, this node is ready to join. Unless Kubernetes right now, I think the direct you were here when I talk about, can we make the Kubernetes as the self-content of the product? I mean, not product. And this is to come up the static part discussing all the other things discussing. Kubernetes itself actually could have API like the public API. We turned down that proposal. I mean, I proposed that one, and the community turned down that proposal a long time back. So then basically Kubernetes it is always part of the cluster. And you have to say this Kubernetes is ready serve class API. Originally, we actually even want Kubernetes support the public API. So it itself can publish pod spec, pod API, right? So that's originally what I thought. So then we could have the start, but that's not all the time. We can start Kubernetes through the Kubernetes evolve with the whole Kubernetes cluster. That's the original thoughts.
Yeah,
Then
but I think Oh, go ahead. Sorry.
Go ahead. And
yeah, I just want to say that in this context, I feel like the metrics are mainly used for monitoring, right? The monitoring metrics. So it's for calculating the CPU usage. In that case, I mean, if we add node startup time, it should be serve the purpose for CPU usage calculating, right? Then in that case, the node ready may not make sense. I know that the metrics can be useful, but in this scenario, it seems that the node boot time may be more useful here, right? If we want to calculate the CPU usage of the node.
Yeah, I want to make sure that we get clarity on this before we spend too much time digging deep in it. So I put an action on here. I'll summarize the discussion we had today on the bug, and I'll take this to SIG instrumentation to clarify why Merrick wanted the node boot time, because I think there's a bunch of different ways we could implement that. And in the issue, he says it's optional. So it sounds like we're mostly aligned in terms of, you know, the container start time metrics. That makes sense. The node time, there's some questions about if we either come to the conclusion that it's not needed, then that solves that problem. Or if we can get more context in why it's needed, then maybe we can move forward. Does that sound good?
Sure. Sounds really good. Thanks, Elana.
Okay,
keep up
I'll do that.
checking the time. And also come back. Thanks for taking this one. One thing I just want to add is the node problem detector. Actually, if I remember correctly, someone added node boot off time to export that as the metrics already. If some production want to use it that way, they could go node problem detector. This is the compromise we have in the past. Let's move to next one. Ni.
Hi everyone.
Thanks.
So I think for as part of the ephemeral containers PRR, I wanted to add a couple of new metrics to the kubelet to answer the following two questions: how many ephemeral containers are running on this node, and how many has this node started? How many were ever run on this node? So I added a couple of gauges, a couple of counters, and the counters are fine, but I think there's some overlap with existing metrics for the gauges. I need to measure specifically ephemeral containers, and there is a current couple of metrics called running pod and running containers. These measure the kubelet's internal representation of containers. So running pods measures sandboxes, not pods technically. And running containers manages just the list of containers, kube containers, not API object containers. So that doesn't have the information I need. I could plumb down the information and like add them as a label or like an annotation, which would be fine. And we actually even had the containerd authors asked for this behavior, so that would be beneficial. But before I knew that, what I did instead was add a new metric to the pod manager that has access to all of these API objects, the pods, and all of their different containers, and surface those as a gauge, counting the number of pods and containers running in this kubelet. So it's clear that we don't want both of these metrics. We could have them. They're measuring slightly different things, but the feedback that I got was that we don't want multiple metrics. It confuses people. So my question for SIG Node is which do we want to measure? What exactly do we want to measure? And maybe even how do we want to call it?
So my concern was not having multiple metrics. It was just that the naming made absolutely no sense to me, and I didn't know what they were talking about. So I just linked a PR in a chat, which was adding the clarification, which is that the running pods thing actually measures the number of sandboxes, not pods as API objects or something like that. So like that's the sort of thing I think would be super helpful. And in the PR, you had introduced this terminology, managed pods, and I was like, what is a managed pod? Are not all pods managed? And so I think just, I wouldn't have any issue with having multiple metrics. My concern was just, I want to know as a cluster operator, what does this metric mean? Because like none of what you have described is well documented or clear. And I want that to be super well documented, super clear, and hopefully like discoverable from both the metric name and the help text.
Yeah, sorry to misrepresent your position. I've actually heard from multiple people that they prefer not to have multiple overlapping things, but it's totally, yeah, I didn't mean to misrepresent what you said in the PR.
Yeah.
And by the way, managed pods comes from pod manager. I am not at all attached to this name.
At least from high level, I do think about there's the lead to introduce metrics for ephemeral container running on the node. But I understand what Elana said, because for the running pod and running container is all it is Kubernetes internal representative. Again, it's Kubernetes internal representative. The reason, just like the earlier Clayton talk about like the synchronization issue, risk condition issue, even actually without those risk condition issue, Kubernetes by design, Kubernetes does the off sync with the API server could be. This is why we introduce, because we cannot need Kubernetes in the middle to block a lot of API behavior. So that's why we maybe have some like the time and different from the API server agree upon. So then we could driving the consolidate and driving our status consolidate and synchronize with the API server. This is why we introduced from day one, we introduced those running pod and the running container concept to, then we can monitor from the API server and also from the node side and see what's the diff. And eventually should be consolidated, right? Should be seen. So at the same time, I want informal container, because running container could be total on the node. Informal container, it is the template and the container we should have to track. Rest stuff needs, but I totally agree with Elana. We should have the well document, and because to represent of the history, legacy, and what we have there. I believe we do have, but maybe scattered to different of the documentation, and over years, maybe people just don't know, don't have the background removed. But I do think the informal container should have the metrics. I want a new feature, such as like the informal container, which it is take really long time. First thing, it is the guard by the metrics. So then we can say that it is behavior well, then we can monitor. We need to build this monitoring dashboard to say, oh, a given of the cluster or given node, how many informal container is running, it is that informal for there, stay there. Then we could give us of paths to clean up those things. People don't abuse those features. Anyway, I just share my top thoughts here.
Yeah, so I guess thanks, Elana, for linking to the PR where the existing terminology was easily confused. So like I think the one with the running pods sandbox clarification is like a net win. I wish we could fix the keys up probably. For this PR, I have no, this all seems super useful. And the managed terminology doesn't upset me because kubelet, its job is to manage pods. So I think that's a fine prefix. I like being able to distinguish by container type on the labels there. And so I like that while you were focused on just ephemeral containers. I like having this for the other container types. So I have no like objection to what you're proposing here, Lee. I have to tie back in your code to make sure it's counting the right thing. The running containers metric we have, I think, historically would have been tripped up by the pause container or not when running on Docker versus the CRI. So having this cleaned up is having something that represents the end user view more than the internal subsystem view makes total sense to me.
Okay, thanks, Derek. I could also pursue a cleanup of the running ones if that's of interest. And these are all in alpha still. Running nomer kind of gets to me because it includes containers that aren't running.
I guess the one question I have is the motivation to know if the kubelet had launched an ephemeral container, I guess, is to know if it was a pristine node, I assume, or pristine workload environment. Are you pursuing this path because we didn't want to put something on the node API itself or on the pod API itself to say that?
No, so this is to help cluster admins with upgrades and downgrades or feature enablement and
Okay.
turn off, just to detect whether the feature has been used anywhere. We are pursuing a pod API level sort of tainted flag to inform as to whether or not it's been ever had an ephemeral container.
Part of monitoring driving development, I call it. I don't know other people call, but I call it monitoring driving development. So that's why I hope let's just make that the scope smaller. Only add like an informal container and information, and not overcomplicate the existing API. I think that's also Elana's concern, like we change this running part, become to management part, all those kind of things, but we don't have to document because running part, the running container actually is being legacy being used for a long time, and people maybe already monitor those things. We used to be want to change that. People just say, oh, no, don't change it. I already monitor those kind of things. So let's just add this kind of things. If we want to do the bigger surgery and consolidate everything, I think we need to call out on even what Derek said, like node API, more serious that way, then let's call out that separately. Is that okay?
Node currently doesn't have
Trying to make sure I understand,
metrics.
Don. Are you for or against the metrics he's proposing? Like to me, these are all perfectly fine.
Yeah, I'm totally fine, but I just want Lee to narrow down the scope because I think Elana have the concern. It is just rename certain things, and which is not well documented. So, but the existing things is being used, being there for a long time. So this is kind of a further delay, basically, and I would just suggest just narrow down only like the focus on the informal container. And is that okay for this one? Because I basically driving this one as the monitoring driving development for me, because every feature in the past, every feature I did, my first question to engineers is how to monitor, how the cluster admin. And Lee actually is SRE at Google, so he basically have this kind of momentum, like the model, how to do those things, I believe. So that's also what I like, and I think that's helped us to figure out the issues for any new feature rollout.
Okay, and just to make sure I understand, so I am solving the problem that I need for ephemeral containers, but also surfacing the other types and not just ephemeral containers, and you're okay with that too. The container type as opposed to only a metric that's only ephemeral containers.
Is that okay with everyone here? So we can
I find that
unblock.
immensely useful.
Yeah.
I'm fine with having a ephemeral only one.
Yeah. Thanks, everyone.
Oh, wait, I think we just agreed to two different things.
Oh no, sorry if I
Yeah.
took them poorly.
Yeah, so I think the metrics in the as is here modulate some better documentation. I'll go back and try to explain what they all are better. Are we agreed that this is okay to proceed?
I think we only want to add the ephemeral one, right? Not everything. I mean, that's what I heard.
No.
That's what I heard from Don too.
I would like all three, and I like the label he has.
Actually, I also have some question about this, because to me, this is not kubelet. It's not the actual state, right? I feel like it's important for the kubelet to report metrics for the actual state, because those are things you cannot get from anywhere else. But for this one, actually, to me, it's just some category counting of some API object. In that case, you can just easily do it in the API server. Right?
Yeah, API objects, I don't think we should be trying to do in the kubelet, because as I said in the chat, the kube state metrics will scrape this from the API server. The API server is the authoritative source, not the kubelet. So we shouldn't be trying to get that from the kubelet.
Yeah, in theory, actually, even the ephemeral container can just read all the pods and counting them, and also check what the node is scheduled to and get the exactly the same number, because it's just desired state and everything's in API server. I feel like it's and especially as Don mentioned that whenever we add metrics, it's hard to deprecate because people may start depending on it, and we may only want to add it when we fully understand the use case. Like this one, I understand that we want to know how many pods, whether this feature is actually being used, but even the ephemeral one, to me, we can get it from the API server by monitoring the pod created and or updated. So
I think it's useful to know.
Go ahead.
Sorry, I was just gonna say, I think it's useful to know how many containers and pods the kubelet thinks it's managing, right? Because the kubelet is not the API server. You could pull the intent, but the intent is different from the actual state.
Exactly.
And also, I'm sorry, I don't actually know the answer to this. There are other types of like the static pods and mirror pods are all of these reflected in the API as well. Well,
I want to add Lantau, I don't think about we are disagree with Chad here. I also want every single thing Kubernetes especially export. It is actual state. I believe this informal container also it is in this category. And the API server, like what you just say, that desired state, that's exactly how Kubernetes today export of the running pods and the running container. That's the actual state, right? So what Kubernetes
yeah.
So there's no difference. That's why I don't understand the.
My question. Oh, go ahead.
Go ahead. What's your concern here? Because I believe.
My question is mostly to. Maybe I need to review the code, but to me it seems that it's counting desired. It's counting desired state instead of actual state. Yeah, if it's counting actual state, then I'm fine with that. It's just not quite clear to me.
It looked to me that you integrated this in Pod Manager, and that should be reflecting actual state. I mean, I'll have to run it to check, but like, I find this useful in the case of knowing, did a kubelet actually get the watch notification that the API server said should be there or not? Like, I don't think the API server is always the one true source. And so as long as this is actual state, it's fine.
Hey, Lantau, a quick look at the code. He's making the call to start the ephemeral container, and then he's checking the result. So the counter is after the result is successful. It may not currently be running, so it's not an actual state, but it is the fact that they were successful in running an ephemeral container of these various types before responding for this metric.
Okay, I see.
So it does have that value, right, as a kubelet metric.
I think this is back to the Clayton earlier said terminology misalignment. I can say both represent some level of the actual state. Now I understand where Lantau came from. So, but it's not actually the container already running. but it is what Kubernetes understand informal container, and on this node and suppose run. Okay,
Sorry, we're actually talking about two different metrics. The one that is updated is the counter of has an ephemeral container been run, and there's another metric of it's a gauge of how many ephemeral containers are running right now.
Uh-huh.
Right. Okay.
Okay, both is actual state to me to some extent. From the API server perspective, I think. Can we carry on this one? I think we really ran out of the time. Carry on the rest of discussion. At least I think from high level we agree Kubernetes can expose some of the metrics represent the actual state, and the informal container account metrics. Actually, it is useful for the cluster admin, and but how to represent, and can we layer down or not layer down, and how we can carry on the PR. Is that okay?
Yeah.
Sounds great. Thanks so much, everyone.
Thank you, Lee. And Swati, and sorry we didn't track our time very well, so you missed today. And next week your topic will be the first one. We will make sure your topic is the first one to discuss.
Thank you.
Sorry.
Thanks, everyone.
Thanks. Bye bye.
Bye, folks.